Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
You sound like a radio announcer.
Well,
you've been doing this a while, haven't you?
If you say my name fast, people think it's Kirk Ray, R-A-Y.
Okay.
So having the two hard syllables.
A pause there and
like
make it nice and clean.
Makes it right. Kirk Gray. No, not Kirk Ray. Kirk Gray.
So. You don't even know half the problem with people not pronouncing your name right.
And then I have to spell it for them. It's not G-R-E-Y. It's G-R-A-Y. It's
the same color.
How many ways can you get an 8-letter name?
Well, quite a few apparently.
Yeah, apparently. Yeah, Shuckelberg.
Yeah, there's just don't call me.
I won't even start with that.
I know.
Fred.
Yeah, Fred. Just call me Fred.
Fred S.
That's it. And that's, if you're listening to this and, if you got a question, don't bother spelling my last name. My email is FMS. I've always convinced whatever company I was working for to use just my initials, even if they had a policy of first name, last name. And I call the IT guy and says, do you want to spell this every day? Over and over again, come on, just use my initials, and it's all right. And so anyway, just call me Fred. That works just fine. Hey,
okay.
Somebody did write to me and said, hey, hi, Fred. I got a question for you. So, this one I'll paraphrase because I don't know enough about what they're trying to do or what the deal is or whatever.
Okay. Mm-hmm.
But the question boiled down to that we have an LED based projector bulb. And so it's some high intensity bright light to show a movie or something. I don't know exactly what they're doing.
Okay.
And okay, I know a little bit about LEDs. I've worked on them on and off over the years, different things, and they fade with time and do all this other stuff. And he goes, well, how long can we store them? And I says, I don't know. They're solid state. They should last, 5-10 years easy. And he goes, yeah, we know that, but we want to put it in storage in argon envelope at 14 degrees Celsius. It's like long-term storage. And he was like 250 years minimum. I'm like, what? I don't know. Okay. But I can't find anything that says LEDs will last that long or not. And I says,
this is an off state. You're talking about storing something in an off state for 250 years.
Right. We don't have any silicon devices that have been around for more than 70 years. I think the very first ones, and they probably don't work anymore because they were just prototypes and moved on.
But we have a lot from the 70s and 80s that still work fine, like my pinball machine. It's 30 years old, and that still has the original chips and the conductors.
Yeah, and they get used on and off, and
all that,
and stored, and
and transported, and moved, and it's probably been in many arcades in its life, and no problem, So
30 years is 1/10 of what they're asking for.
Right, and so they're really going to have to just say, what is any kind of diffusion? I mean, they better get started now.
That was my first thought. Is that isn't? Correct me if I'm wrong, because LEDs are based on basically a p-n junction. There's a difference in silicon doping, and it creates a light when it's got a voltage across it, and it sends off a bunch of photons, and it's just that. But if that doping, what I don't know about silicon is, left to its own devices, there's a concentration of more or less on either side of this barrier.
Right.
Just left to their own devices, will they, no pun intended, on their own, will diffusion balance out that gradient, the difference between these two sides of or is there some other barrier there?
You have a P and an N. It's doped with excess of either holes or carriers.
Yeah.
One side. Okay. And they are now implanted, so it's a very precise, more precise position in the layer of the silicon. But I guess there's you look at the basic mechanisms in silicon, hot carrier injection. It's a very simple device. Obviously, I mean, it's a single PN junction that emits light,
right?
And it's probably, I would say, it's been my experience, and I think everybody probably had an experience where there are LED lights that hopefully everybody has in their house instead of incandescents now.
It's because the law here in California anymore.
Really?
Yeah. I think they had banned the 100-watt ones a long time ago, years ago. Now it's down to 20. You can't even get 25-watt bulbs anymore. There's some specialty ones that are still available, but they're expensive. Yeah, the incandescents. Yeah, you can get. And the hardest part is converting it. Like 100-watt is the same as a 6-watt LED or 8-watt, halogen or this, or it was like whatever. Or now they're all using lumens, and they're like, what in the world is a lumen? But I digress. So anyway, what happens if it's just sitting there? Isn't there something like the second law of thermodynamics that doesn't like things that have? It's going to, because it's doped. There's going to be, the lack of a technical word for it, a tension between the two sides of the junction. There's going to be a gradient due to electrons on one side and not enough electrons on the other side.
Yeah, but they don't do anything just in a no charge state. I mean, they're not. I don't believe that they may move in the lattice. They have
to move in the lattice because they're not at absolute zero. They will move.
They're not absolute, right. But I don't know. There might be some diffusion, and that'd be a good question. And first experiments I would have is to try and find somebody that's had LEDs somewhere, or do your research that somebody's had something sitting on the shelf and an LED production facility or somewhere for at least 10 years. Let's say we, as a technology, of course, that's the problem with
we keep changing this stuff. We keep changing materials in the process. Yeah,
exactly. And the assembly methods and all that. But I think all of us have had, light bulbs, even that LEDs that have failed in less than, they're rated 7, 8, 10, whatever.
Well, yeah. And that's, they get so many thousand hours. That's manufacturing variability. It's sitting over the stove and it's got boiling water, steam going into it all day long. I get that.
Right.
That varies.
No, some of them are just in my house, just in the
ceiling. That's your house. Yeah, that's your house.
Well, I think you've ever had an LED light bulb fail, Fred.
Oh, yeah. Well, regularly. Usually the one closest to the stove.
Okay.
It is.
Okay.
It's not in your house where you got flying parts of blenders flying around the house.
No, not recently. But anyway, now the question is, and this is, I wouldn't know. I would certainly question the PN junction itself and try and find about as much physics of understanding of what they suspect will be those drivers in a storage situation for that PN junction. But the other issue is there's got to be, it's not just a PN junction. There are wire bonds, there are connections to that PN junction to make it work, to make it have current flow.
There's a power supply. And that was my second thought was if you've got an electrolytic cap there, just sitting on the shelf, they dry out.
Right. Yeah. I wouldn't rely on any of those time device, but you could do solid state caps, but there might be some aging to those. I don't know at this
polymer film
scale,
ones. Yeah, polymer film
100 years. There's not been around 100 years. We haven't had any.
Right. No, and so he sent me. They sent me this paper from Texas Instruments looking at shelf life because I guess people were throwing away components that after they've been on the shelf for 2 years. Just saying, we'll throw it away. And they did a study saying, no, they're just fine, and it's like, well,
it's not like food where you might worry about spoiling.
Well, if you store it in a, salt, a locker underneath a dock on the ocean and you got nothing but salt spray all day long, it's probably got a problem. Right. But, just sitting on the shelf and it's going to be fine. And And the gist of the paper was it didn't go into great detail, but it was, 5-10 years for most electronics. We've not seen any evidence of any, problems. But it was based on accelerated testing and the typical component, test 77 of them for a day or two under temperature. And, and it was, and I've done other shelf life things, and it always comes down to exactly what you and I just talked about was, well, what's the failure mechanism?
Right.
Even if it is very slow in 100 years, that may matter. And so my first thought was, we don't worry about very slow diffusion on PN junctions when it's on an iPhone. I mean, it's going to be on the shelf for what? Hours, in some cases, maybe a little longer these days, maybe a year. And then it's going to be in your hand for 5 years or so.
Right.
And then eventually you drop it one too many times and you got to get a new one. And no, that's not. They generally are technologically obsolete and they're no longer supported. Yeah. You can't upgrade them. You can't get the latest software. Your programs won't run because it's asking for too much memory. Those are the things that you hope that the manufacturer is improving on to make it use a reason to buy a new phone, not because you broke one or it wore out. And that's not. We just don't have all of our electronics usually becomes technologically obsolete. And like I say, the only one I have that I'm still, using that's 30 years old is the pinball machine. Yep.
And other things, we usually get rid of because we've got, I've got, and I just think it wouldn't be the problem of, the question of storing a CD, for instance, for 100 years. Well, good luck in 100 years if you can find anything that'll read a CD.
That's right.
I know.
Yeah.
It's like, what are they expecting this, and 250 years, somebody's going to look back at this thing or whatever. Yeah, they can probably.
They're going to go to Fry's. They're going to go to the computer museum and pick up an old Atari and stick it in that and read it. But the idea is, I mean, whatever their preservation project or whatever the idea is, and it sounds like they're thinking it through, is get rid of oxygen. That's just bad for everything.
That's true.
Get rid of the moisture. Put it in an argon envelope, keep it at a steady temperature so you're not dealing with thermal cycling as much, right? Because nothing will keep it at a perfect 14.00 degrees Celsius. It'll vary slightly, and even a little bit matters over a very long period of time.
Yeah, could.
And so my initial thoughts to the guy was, well, what is the mechanisms that will eventually take this apart? We don't typically investigate those things because of just what you said, Kirk, because this product's only going to be on the market for 10 years max, and it might be around for 10 years after that. And then good luck. We're moving on.
Right.
And then the other part of it is, my second thought was, what if this technology just doesn't last? And we just don't know because they haven't been around long enough for us to ever even explore that, or this use case is not its purpose. Right. So let's take a look at it a different way. You need backup. And he says, well, we're going to put an extra bulb in there. Well, the second bulb just, if they both fail for the same reason over, that's not going to work. How about a different technology? And he says, how about an arc lamp or, a different method? And then how about a third method of write down the direction, schematics or the directions or, something that can be interpreted, how to build one of these things. What's the concept? Put enough light through this small opening and you can see it, kind of thing. And
well, it's kind of like the record that they put on the Voyager, the gold plated record. Who knows what's going to find it if it ever is found by another civilization or read, but the idea was it was built to last, hopefully 10,000 years, because that may be how long it'd take for any other civilization to find it or whatever. And in it, I think they contain the instructions on how to read it, sort of. And of course,
it's all pictures. It's all, it can't be, it's not in English or Chinese or anything. It's just.
But we don't know what kind of life forms are out there and whether they can even visually see things, or they'll be looking at different wavelengths. They might miss it altogether. You never know. So
You never know.
it's just a kind of a shot in the dark. And I'd say for these guys, they got to list all the known mechanisms in this whole functioning system, other than the p-n junction,
Yep.
and then list what they can understand, what they can find out from past field, actual real running time or not storage time.
Just that's the hard part. A lot of people in electronics don't really consider storage time. I mean, there are canned foods and stuff that are stockpiles, or there's different things that are put into stockpiles, like medical equipment. I remember when COVID was first coming around, it was like, well, we have a stockpile of ventilators, and they're pulling them out, but not enough. But those get some due diligence of, can we store them for 5 years or not? I know when I was in the Army, the munitions that we had to maintain and rotate, and they didn't have an infinite shelf life, and they were long, but once they started getting close to expiring time, they would be taken to ranges and tested to see if they still worked, or put into training facilities or sites and stuff. But a lot of that stuff couldn't be, because it was way too powerful for training. And so, but like in the illumination rounds that would blow up and then in the air and then hang with the big light, basically. Right. That, I think it was phosphorus. That would degrade. So that had a very short shelf life.
Well, you're talking about chemical, ordnance that has, basically chemistry. So that's going to degrade over time. But a solid state device is going to have much slower aging mechanisms.
Well,
especially
we think so. And I think you're right.
I think all the evidence there. And I think what you're going to have to do is take your knowledge at this point in time, because you really don't know. I mean, you can try and find things that have been in storage, LEDs, whatever your mechanisms. I mean, you got more than just the p-n junction there. So you're going to be looking at what past, if you can find companies that have, and I imagine some of these manufacturers of LED lights have set something aside and see how the storage is, and have some aging because they have to store. But they would have to go to the people, the chemists and the engineers that have designed this thing, and find out what the longest running or longest storage that they could find on that similar device, and then try and measure whatever they can measure.
Yeah, no, I agree. It's a combination of literature search to figure out what are these mechanisms for when it's not in use, in order to what would rear its ugly head, not just the p-n junction, but all of the other components in this system. But they were, for whatever reason, concerned about the bulb, and they weren't concerned about all the other stuff. And I thought, well, that's, you need to look a little beyond this.
I'd say the bulb is probably depending on the assembly of the bulb, the p-n junction itself is probably the least of their concern.
I listed stuff like, they're in an oxygen-free environment, so it's anaerobic, right? It's no oxygen. There's certain
can't oxidize, right?
No, can't oxidize, but there's certain bacteria that loves that stuff. It's called botulism, for example. And if you have any, contaminant on this anywhere, like it was ever in the air, there's a biofilm on it. And if it has no oxygen, then these very aggressive things will go find food. They will break down stuff. They break down wood and sell in chip and all this other stuff.
I would use non-organic materials in here, or nothing that would provide any kind of nutrients to anything.
Well, there's bacteria that goes after oils, and sealants and rubbers and all this stuff.
Right. If there were plastics in this thing, I would worry about them becoming, the potential aging of that, even though being in a non-UV environment where you can't be exposed, keeps the cross-linking from happening, which in most plastics makes it very brittle. And,
I think they're thinking through, the storage conditions for many, many things. But so the first step I thought was, let's just do a brainstorm or do literature search, gather it all, organize it in a fault tree, and then figure out which one's the ones that is the most likely to limit the life of this over time. And then Fred, then figure it out, and then run a test. Wait, I'll take it to Hawaii, and we'll sit there for 200 years and see how it goes. Then you'll know whether it lasts 250 or not.
But see, now you have to also worry about the storage, containers and the storage medium, the argon, and whether they're going to leak out. And, you're talking incredible, it's not just the device itself, but if you've got
the whole system.
The precision storage conditions, are they going to last 250 years? Probably not.
Probably not. No, they must have some good funding in order to do that. Maybe they should just plan on 150 years from now inventing a new projector, and then 200 years from now do another. Here's the specs. Exactly. You guys design one.
Yeah, I think it. In that case, you just keep it simple. What do you have that we've discovered after, it's been 250 years ago? Ruins. I don't know.
Well, no, the only thing I know of, the one that comes to my mind is that when you go into Europe, especially, and you see the early windows were very small, and they were blown glass, and then they would they'd take the molten glass and lay it down into a frame, and you could see the markings of the way it was made in it. And then if you look closely at those glass, it's thicker, noticeably visibly thicker on the bottom than the top. The glass, which we think of as, just like steel, basically,
right,
is actually a fluid. It's just that it moves slow. But after 100 years or 200 years, this stuff will flow. It will move. And so it's things like that you got to start thinking through, is not the stuff that make it last for 5 years, or not when it's under power and voltage cycling and all the other stuff that can happen. But you can still get, for example, cosmic radiation, various kinds of radiation from wherever, and that breaks down stuff. Yeah. And you might only have 1 in a million chance per day to get a strike, but you add a lot of days.
Like 250 years. No, I don't, this is just kind of, I would just say that you'd have to just guess, at using your best knowledge of the mechanisms of aging in this device.
And put 3 or 4 backups of different technologies, plus just how to do it. Build your own later.
Yeah. It's like, why would anybody want to see whatever this thing is?
I don't know what they're trying to preserve, but if it's episodes of I Love Lucy, then it's worth preserving. It definitely is. So anyway, if you've got some experience with long-term aging, 250 plus years for electronics. Let us know. We're just curious as all get out as what in the world could go wrong with this stuff. It's just that it's, people talk about reliability of a product, and it's for the warranty period, or 5 years or 10 years or 20 years of a car or something like that.
Right.
That's nothing. That's an easy piece, walk in the park kind of setup. Yeah. Let's, So if you got something on that, let us know. We'd love to hear from you. If you got a question as cool as this one, or just your everyday, question that you're facing, we'd be happy to flesh it out a little bit, chat about it in the show. Head over to accendoreliability.com/go, and you can find a /go/SOR. And there you can leave us a message, or you can find Kirk and I and the other hosts of the show on LinkedIn or our About pages. Lots of ways for you to get in touch with us. And so, it's long term is it's a different problem, definitely.
Right. Make it out of stone.
It's
That's about it.
Even that won't last all that much.
No, it doesn't. Right. Let's look at the Parthenon, though. It has lasted a long time.
That's true.
Columns there. But yeah, it's just rare that we need anything, and we realize that technological obsolescence has really never allowed us to see the true wear-out mechanisms of so many things in electronics.
Yeah, exactly. All right. Well, thanks, Kirk. Thanks for taking a shot at some ideas on this one and bouncing some concepts back and forth. And we'll talk to you again soon. Take care.
Okay, Fred. Bye.
Bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.